minus r to the 10th, which is r is 5 raised to the 10th term over 1 minus 5. Now, don't panic that you're about to get negative 4 here, because does everybody realize you're about to get a negative number there too? Okay? So we get s of 10 is equal to 3 times 1 minus, well, I don't know, 5 to the 10th. I'm not even going to work that out, over negative 4. Don't panic. Punch it in your calculator. Like I said, if you don't have a calculator, you just leave it right there. All right? You don't have a calculator, you're allowed to do what? Stop right there. Okay. Is that okay? Okay. And basically, this is a matter of putting numbers into formulas. Right. Okay. Now, do you agree? Okay, let me make sure everybody's happy up to here. Happy up to here? Okay. Now, notice here the ratio is 5, so every time I'm adding a number, it's a larger number, right? Okay. Now, let's try something here. Let's try something. And this is going to remind you of what we were talking about last week. Because you remember last week when we were adding, a couple weeks ago, we were adding these numbers, but the numbers we were adding were getting closer to 0. Remember that? Okay. All right, big brain time. This is the biggie. This is the reason I'm teaching you this. We're going to talk about infinite geometric series, where you're adding the numbers up forever. Okay? That's like what we were doing the other day with e and pi. And you know, you ought to get out and do it. Okay, here we go. The sum of an infinite series of geometry is equal to the first term over 1 minus the ratio. But there's a problem. The numbers you're adding are going to have to get closer and closer to what? 0. So the ratio can't be 5 or 6 or 10. The ratio has to be like 1/3 or 1/5. Because you got to be adding what? Smaller and smaller what? Not smaller, but numbers that are getting closer to what? 0. So this only works if the ratio is between -1 and 1. That's the key. Otherwise, this formula doesn't work and you just get an infinite solution. You just get numbers that get what? Either off to positive infinity or off to negative infinity. Okay? But you don't get a nice, pretty number. All right? The ratio for this to work, for these infinite geometric series to work, this is called converge. We can go ahead and not just say work. Let me use the real word. Converge. For them to converge, look pretty, your ratio has to be between -1 and 1. If your ratio is not between -1 and 1, they are said to diverge. You might want to write that down. Diverge. That's the opposite of converge. Converge, they get closer to something. Diverge, they go to positive infinity or they go to negative infinity. They don't get close to something. All right? Now, and this formula is the one you will need more in calculus than the other ones. You're going to have a lot of these infinite geometric series. All right? They're going to appear more than other stuff. Okay. Everybody happy so far? Okay. Now, I'm going to give you a problem. Let's say we start off with 4, go down to 1, and go down to 1/4, 1/16, 1 over 64, dot, 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 dot. Do you notice how what you're adding is getting closer to 0? See how what you're adding is getting closer to 0? key right there. That means this is going to converge. Now, a sub 1 is equal to 4. And what is the ratio equal here? 1 what? 1/4. And is our ratio between -1 and 1? Yeah, so it'll work. So if we were going to add these up forever and ever, you know, just add more and more of them. Keep adding. You know, you give the little kid the calculator while you're babysitting and say, I want you to add 1,000 of these together and tell me what you get. Well, is 1,000 really going out to infinity? But I bet 1,000 in this form is a pretty good approximation, isn't it? You could use infinity, and that'd be a pretty good approximation for going out to 1,000. That way, you remember that long formula I just wrote on the board? If you're ever going out to really big n values, you can shortcut it by using this, as long as the ratio is between what? -1 and 1. Everybody follow that? Don't ever use this unless it's like n of 1,000 or 10,000, and you can cheat it by just using this formula. All right. Well, I want to know what's the sum of all these that you could add up forever and ever. I bet it's a little bit bigger than 5. How many people think it's a little bit bigger than 5? Yeah, because 4 plus 1 is 5, and then I get 5.25, and then add, yeah, so it's a little bigger than 5. Well, let's see what it is. It is 4 over 1 minus the ratio, and what's the ratio? 1/4. So it's 4 over 3/4, and then take the reciprocal of the 3/4 and multiply by the 4, and you get what? 16 what? 16 thirds, which is what? 5 and 1/3. 4, 5, 1/3. I'd prefer for you to leave it 16 thirds, but in any case, I don't mind if you write it as a mixed number, because 5 1/3 gives you a little bit better idea of what's going on. Pretty cool, huh? Yeah. Big E. All right. This one we're going to talk about some tomorrow. Now, yeah, I'm at that point. Tomorrow, I'm going to talk about applications of this. This one right here. We're going to do some cool geometry applications. Now we're going to do that stuff teachers have to do